Hi, hello everybody. So this is the video dealing with section two, linear and compound inequalities. And again, for this section, I decided to split the section into two videos because they're slightly two different topics. So first, we're going to consider the basic linear inequalities. Okay. So these are very, very similar to linear equations, but there is one minor difference, maybe, or maybe two. So first of all, the equations are not really called equations because they're not based on the equal sign, right? They're called inequalities because they're based on these four symbols, okay? The first one is less than or equal, greater than, greater than or equal, okay? So these four symbols, we call it the inequality symbols. So if you have an inequality, it's going to involve one of these symbols and not just the equal sign. Now, what's important here is, in addition to these four symbols, is one, um, that once we reach a solution, let's say, for example, compared to what we had before, let's say x equals 9. That means that 9 is the only solution to x because of the equal sign. If we have something like, let's say, x less than 9, now that means that any number less than 9 is a solution. For example, 7 is a solution. 6, 0, -3. How about 7.1138? Yeah, that's a solution. How about -3.1177777777 forever? Yeah, that's also a solution. So these inequalities, we may have infinite solutions uh, as answers. So we can't list them all, right? That would be very, very difficult because we have infinitely many numbers. So we have to devise a way to specifying or writing the answer in a way that is compact. So that's number one. Number two, okay? Uh, the answer is going to be expressed in what we call interval notation, okay? And I'm going to show you what that is in a minute. Number three, we are still going to do, in order to solve these inequalities, we're going to try to balance the inequality or the equation before with the plus, minus, multiplication, and division operations in the exact same way as we did equations, right? Well, there's only one difference. Whenever you multiply or divide by a negative number, if you multiply or divide by a negative number, the inequality is going to change sides. So for example, if I have something like this, okay, and I divide just by a positive number, that's okay, right? These two threes cancel just as before, right? The answer is still greater than 1. Now, if I had this, for example, okay, we don't care about the negative here. We care about the negative here. This side, I have to divide by -3, which means I have to divide by -3 over here. So these two -3's cancel. I end up with an x here. The 3 divided by the 3 here, it's still going to give me the -1, but because I've divided by a negative, this inequality is going to flip. So if it was greater than equal, it becomes less than or equal. If this thing here was, for example, less than, then here it would become greater than. So whatever this thing is, it flips to the other one. So this only happens if you multiply or divide by a negative, right? So that you have to remember. So I left a notation here for you guys to see. It's always also in the workbook so that you know exactly how to do this. Other than that, the process is very, very similar to solving an equation as we've seen before. Now, because the answer has to be in interval notation, okay, we need to be able to write this in the way that the answer must be written. So, for example, let's say you worked the problem and you ended up with x greater than -3. We have a process through a graph and then the interval notation for us to do to make it easy for you to reach the interval notation. So first we graph the greater than -3. So we graph the algebraic solution. So here's the number line, right? The numbers increase this way and they decrease that way. So this is 0, 1, 2, 3, and so on and so forth. -1, -2, -3. So here's my -3. Okay. Now the inequality symbol says greater. So greater meaning to the right. Okay. So I would shade it everything that is on the right of -3 here. Obviously, I can't shade it forever, so I indicate that by the arrow. All right. Now, if the inequality symbol does not have the equal sign, we use parentheses. If it does have an equal sign, we use bracket. Now, look, so this is the graph. What I wrote here for you is the graph. So for example, if the equation had been greater than -3, I would use bracket, right, and going to infinity. If it was, for example, x less than 4, here's my 0, here's my 4, no equal sign, I use parentheses, and we would shade it going to the left. We'll see an example. Now, looking at the graph, okay, erase this. Looking at that graph, the interval notation is the notation, the algebraic notation of the graph. So for the x greater than -3, it would be parentheses, -3, comma, positive infinity. We'll see more examples, don't worry about it. Okay. If there was a equal sign here, bracket, -3, comma, infinity. Now, the infinity can go to either side, positive or negative, and we always use parentheses with it. If it's on the right, it's just positive infinity, and if it's on the left, let's say something like this, negative infinity. Okay, always parentheses, never bracket. All right, so let's see how this is done. So the explanation, I think, is sufficient for now without making this video, 40 minutes long. You can always, and you should always, read the workbook before watching the video. All right, so let's take a look at example 2.5. So notice, solve and graph the solution. Now, on the exam, you won't need to graph, but the graph helps in writing the solution in interval notation, okay? So we're going to solve the inequality as if it were an equation, okay? Just pretend the less than symbol here is the equal sign. So we have to move all of the variables to the left, all of the numbers to the right. So I'm going to do -3x here, and obviously -3x there to balance the inequality. So I get -5x plus 9. Here they cancel, -11. Right? So minus 9 now to get rid of that number. Notice it's exactly the same, negative 20. Now, at this point, I have to get rid of the negative 5 that's multiplying my x, and I do that by dividing it by negative 5. And because I do that, first these cancel. The negative divided by a negative is a positive. 20 divided by 5 is a 4. But this symbol flips to greater than because you've divided by a negative. So remember, if you divide or multiply by a negative number, the inequality symbol shifts. So this is my algebraic solution. Now, this is not enough. We need the answer in interval notation. Well, Professor, why do you do that? Why do you need that? Because there's an infinite number of solutions here. So the solution is x greater than 4. So for example, 4.1 is a solution, 4.001, 4.0003, 4.7, 5.1, 19.3, 1,000.78. There's just too many. It's infinitely many solutions. So we can't list them all. So what we do is we write the answer in interval notation. So first, here's the graph. Here's my 0, 1, 2, 3, 4. Right, here's my 4. And I'm going to shade it in the direction of the inequality. Right? Again, the inequality says greater. So from here, I'm going to shade it to the right. Okay? So notice that we started with a less than symbol and we end up with a greater than. Now, because there's no equal sign, we put parentheses here. So the solution in interval notation would be parentheses 4, comma, infinity. So this is what we need to see. The graph is optional. You can do it on your scrap paper, but this is the solution. Not only this is the solution in interval notation that we need to see. Okay? All right, very good. So let's do the second one. The second one is a little harder because we have parentheses. So as before, remember, when we have parentheses, we have to remove the parentheses first. So we distribute the 7. So we get 7x plus 14 less than or equal 4x minus 1. And now we solve it at this point as if it were an equation. So minus 4x on both sides. So I get 3x plus 14 less than or equal to these cancel, negative 1. And we subtract 14 to both sides because we cannot have the number here. So that cancels. And we have negative 15. Now, notice you have to get rid of this 3 right here, but you just divide by 3, not negative 3. So these two 3's cancel. And I have, is it this symbol or is it the other symbol? Well, the symbol doesn't change, right? Because I am not dividing by a negative as I did over here, right? Take a look at the previous example. We've divided by a negative and then the symbol did change. But when we divide by a positive number, the symbol does not. So the solution is x less than or equal to negative 5. Okay, but now we need to find the answer in interval notation. So we're going to graph it first. So here's my 0, here's my negative 5, and I'm going to shade it in the direction of the inequality, which is to the left. So from here down, I shade it to the left, and I indicated with an arrow that it goes on forever because I can't shade it forever. And because of the equal sign, we use bracket. Okay. So if there is an equal sign at the bottom of the inequality, we use a bracket. Otherwise, we use parentheses. And now we are going to represent this interval in this color. in interval notation. So we always go from left to right, right? So negative infinity, comma, negative 5 bracket. This is the solution for that problem. Okay, so this is how you solve these inequalities. There's still simple inequalities, linear inequalities, and we have to remember that they're kind of solved the same way as equations, but there's a couple different things. Number one, if we multiply or divide them by a negative number, the inequality changes, right? So if I have this, it changes to that. If it's greater than, it changes to less than. If I have greater than equal, it changes to less than equal. If I had less than, it would change to greater than. And if I had less than or equal, it would change to greater than or equal. Only if you multiply or divide by a negative number. And number two, the answer has to be given in interval notation. Okay? So this is the first part of the section dealing with inequalities. And in the second video, we're going to see compound inequalities.